So we're moving on now to a type of calculation called the limiting reactant calculation, and this is found on page 8 of your quantitative chemistry booklet. This calculation isn't very much different from the calculations we looked at last, called reacting mass calculations, because you're still trying to work out masses from one part of an equation to the other part of the equation. With this type though, it's a little bit trickier. There's a couple more steps to do within the calculation. In terms of what it is, let's read what it says at the top here. All the calculations we've done so far have assumed that you have enough of both reactants to a perfect reaction with nothing left over. However, a bit more realistic would be, this line here, normally you have a reactant left over, and it'd be referred to as the excess reactant. And the other reactant is all used up because there isn't any more of it, and it limits the reaction. In other words, it's called the limiting reactant. What that's basically saying is that in most normal reactions between two different chemicals, you're going to have slightly more of one than the other. So one will be used up first, and one will be left over at the end. And we have to kind of cope with that in terms of our calculation as well. What it actually looks like is the example here. So the start of this looks pretty much the same. So you're given an equation, copper plus sulfur makes copper sulfide. There's a slight twist to how they give you information in the question, and this is what you're going to have to spot in the exam. It says that 9.6 grams of copper is mixed with 6.4 grams of sulfur and the reaction mixture is heated. What this question is going to ask about is trying to work out how much copper sulfide you form on the right hand side. The thing to spot in this type of question, to tell you that's different, is that they're giving you two different masses at the start. In all the questions we looked at previously, they only give you one mass at the start. But here we've got a mass for the copper, 9.6 grams, and a mass for the sulfur, 6.4 grams. So we have to work out what we do to cope with two numbers. So I'm going to go in a second to have a go at this calculation to show you how you do it. But before I do, I'm going to make a wee analogy to maybe help you try and understand what's going on here. So let's say in the future, once everyone escapes lockdown, if I decide I've had enough teaching, I want to go and work in a bun factory. That's like my lifelong dream. Let's say my job in this bun factory is to put the cherries on top of the cherry buns. So if I have on my production line 3 baked buns without cherries, and if I also have on my production line 4 cherries ready to go to put on top of the buns. The question to think about here is, how many complete cherry buns can I make from 3 buns and 4 cherries? Hopefully it's not too much of a stretch to work out that I can only actually make 3 complete cherry buns with the cherries on top, because I've only got 3 buns to actually work with. I'm going to have a cherry left over without a bun to put it on. Bringing a wee bit of terminology into that, what we're basically saying there is this reactant, the buns, were the ones that ran out first, so they control how much of the product, the finished buns, actually made. What we refer to that as is the limiting reactant, because it's the one that limits how much of the reaction takes place. I can only make 3 buns if I've got, or 3 cherry buns if I've got 3 buns to start with. What we refer to the other part of the reaction would be the excess reactant. Because with regards to the cherries, it didn't actually matter how much I had because I've got more than enough of them. If I had 10 cherries, I couldn't make any more buns. If I had 20 cherries, I couldn't make any more buns because my limiting reactant is controlling that. The excess reactant is always going to be left over. So with that analogy in mind, let's have a look at this one with the copper mixed with sulfur. Now, how I'm going to actually approach this is the method we've kind of used before, which is the table method. It can still help us here. So I'm going to write out the equation. Give everything its own column. And go for ratio, mass, moles. No, I'll go RFM first. And then moles. So if I look back to the question and see what it gives me, now this obviously is a wee bit different. As I mentioned before, they're giving you 2 masses here, so I actually can put 2 masses in there. So 9.6 grams of copper, 6.4 grams of sulfur. Something I probably should have done at the start is work out the ratio. This one's a nice simple one. Remember, the ratio just comes from the balancing numbers at the start of each bit in the equation. Remember, if there's no number there, it's just one of each. So 1 copper reacts with 1 sulfur to make 1 copper sulfide. So in terms of where we go from here, what I'm trying to calculate as well, it doesn't actually say it here, it's at the bottom of the page, I'm just covering it up. We're going to try and work out how much copper sulfide CuS I can make here. So my target part of this table, the number I'm trying to get is this bit here, the mass of the copper sulfide at the end. So here's the method. Similar to what we did with the easier ones, you generally start by trying to convert your masses into moles because you need to use your ratio to work out how much of a product you're going to make. So I'll just do that for both the copper and the sulfur. Remember, moles equals mass over RFM. So I need my RFM to work out the moles first. Now RFM just for an element is just the atomic mass number. So for copper it's 64 in the periodic table and for sulfur it's 32. So to work out the number of moles of copper, I'm going to do 9.6 grams divided by 64. That is 0.15 moles. And for sulfur, I'm going to do 6.4 grams over an RFM of 32, which gives me 0.2 moles. Okay, here's the really important part of the calculation to work out. Okay, I need to work out the number of moles of copper sulfide I'm going to make here. But the tricky bit is I've got two different mole values for my two reactants. So I'm going to need to pick one of them to carry across and use the ratio to make the product. What I need to identify is the limiting reactant and the excess reactant. Similar to what I did for my analogy of making cherry buns from buns and cherries. I need to work out which one's going to be used up first and therefore control how much product I can make, and which one's going to be left over at the end. With this one, it's not too tricky. Because there's a 1-to-1 ratio, we'll look at ones later on where it's a little bit more tricky in this. I'm safe enough just to pick the smaller one as the limiting one. The 0.15 moles of copper will be used up before the 0.2 moles of sulfur is used up. So this is going to be the limiting reactant. And the sulfur is going to be the excess reactant. It's left over at the end. The limiting reactant controls how much product I make, so it's this number of moles I use for my ratio to work out the copper sulfide. The excess reactant, once I've identified as excess, doesn't actually matter that much to the calculation anymore. I can ignore it. So with that column ignored, basically I just treat it like a normal mole question now. I've got my moles of my limiting reactant. I use my ratio to work out if I've got this number of moles of copper, how much copper sulfide will I make. It's a 1-to-1 ratio. So I will just make 0.15 moles of the copper sulfide. Almost there now, I need to work it back into a mass. So I need to do my rearrangement. Mass equals moles times RFM. RFM of copper sulfide is just 64 plus 32, which is 96. So to work out the mass, I need to do the moles, 0.15, times by 96, the RFM, which gives me 14.4 grams, which is the answer. So going over the tricky step just very quickly again, the general method is two masses convert into 2 moles. From my 2 moles of my reactants, I need to work out which one's limiting and which one is excess. With a simple one like this, when it's just a 1-to-1 ratio, I'm safe enough just to pick the smaller one because the smaller one will probably run out first. And when I want to work out which one's going to run out first, it's the one that's going to control how much product I make. So that's why I picked the copper, 0.15, 1-to-1 ratio, 0.15 moles of copper sulfide, converted back into a mass at the end. So I'm going to work through a couple more examples now just to see if that can help it get into your head. Now there is an example on the bottom of page 8 involving this NH3 and O2 going to NO2H2. I'm actually not going to do that one. I think it's actually quite a tricky example to start with, so I'm going to ignore it. I'm just going to make one up here on the page and see if you can follow through with me. So it's simple enough reaction, you've done it in the acids topic. We're going to look at the reaction of hydrochloric acid with sodium hydroxide, which is just neutralization, to make sodium chloride plus water. In this particular made up question, I'm just going to say, it tells you in the question that you've got 73 grams of HCl, you've got 60 grams of NaOH, and you're trying to work out the mass of water at the end. So hopefully you see that this fits into this limiting reactant style question because they're giving you 2 masses at the start of 2 different reactants. Again, I'm trying to work out a product here. So, going to do the same method as before. I'm going to construct it into a table. Okay, so I'll start by just looking at my ratio first. That's probably a good place to start. I've got 1 HCl, 1 NaOH, 1 NaCl, 1 H2O. It's just a 1 to 1 to 1 to 1 ratio. So again, it's a nice kind of simple version of this question. Next thing is to fill in what I already know. It gives me two masses in the question. I've got 73 grams of HCl. I've got 60 grams of NaOH. What the question is asking me to work out is the mass of water at the end. So in this case, because there's 4 columns, I don't actually need this third column. The question's not asking me anything about the sodium chloride. It could on another question, but in this one it's not. So how do I approach this question to work out the mass of water I get at the end? Do what I did before. I've got two masses of two different reactants. I'm going to convert them into moles and compare the mole values. So for HCl, to turn that into moles, I need its RFM, because moles equals mass over RFM. RFM is 1 for the hydrogen, 35.5 for the chlorine, so 36.5. So to work out the moles, I need to do mass over RFM, 73 over 36.5, which is just 2 moles. Same thing for sodium chloride, or sodium hydroxide, sorry. 60 grams of it needs RFM to work out into moles, and 23 for sodium, 16 for oxygen, 1 for hydrogen. Remember, that's all off your periodic table, the mass numbers. Gives you an RFM of 40. So moles is 60 divided by 40, which gives you 1.5 moles. So now it's a tricky bit of the question. I need to work out which one of these reactants is limiting, which one's excess. The limiting reactant is the one that runs out first. So I need to think it's a 1-to-1 ratio, so one of this reacts with one of this. The one which is going to run out first is going to be my sodium hydroxide, because I've only got 1.5 moles of it. There's going to be some HCl left over, because there's going to be 0.5 left over once that 1.5 reacts. It's going to be the excess reactant. The rule is now, I kind of ignore my excess reactant because it's always going to be left over. Doesn't matter how much there is. But my limiting reactant is going to be used up, and it's going to control how much product I make, how much H2O I'm going to make at the end here. So having ignoring that HCl column now, I use my ratio to work out from the moles of NaOH how many moles of H2O I'm going to make. It's a 1-to-1 ratio, so nothing really to do here. 1.5 moles of NaOH will make 1.5 moles of H2O. Almost at the answer now, I just need to turn it back into a mass. So to turn it into mass, I need to do mass equals moles times RFM. RFM water is 1 plus 1 plus 16, which makes 18. So my final answer is 18, and the RFM times by the moles 1.5, which is 27 grams. And that is the question complete.